my study, I conducted a systematic literature review to look at the effect of a high glycemic index diet on metabolic characteristics such as body composition and glucose homeostasis in mice and rats. So we looked at 4 databases: PubMed, Web of Science, Scopus and Medline, and we used preset inclusion and exclusion criteria to select our studies. This criteria included that the diet has to be a high GI diet and not just a standard diet using a high GI supplement such as sugar in their water, and needed to be in live mice or rat non-transgenic models, and the diets needed to be greater than 50% carbohydrate and greater than 90% protein by energy. So using this criteria, we found 30 studies, 14 in mice, 14 in rats, and 2 using both. And with these articles, we then extracted the relevant information in regards to body composition and glucose homeostasis, and we conducted a methodological quality assessment, which was a set of 22 binary questions assessing the reporting and experimental design of the studies. So shown here is the mouse data and representation. So this is a comparative effect of a high glycemic index diet compared to a low glycemic index diet. So our upwards arrow indicated that a higher GI diet have increased compared to a low GI diet. A tilde indicates they have an equivalent effect, and black spaces indicate that trait was not examined in the study. So we can see that for body fat in particular, there was a general consensus in that most of the studies that looked at it had an increase on a high GI diet compared to a low GI diet, but for the rest of the factors it's not as clear, such as in body weight and fasting glucose, there is quite a mix. And this could be due to one of the interesting things that we found in our MQA, which is that none of the studies that we looked at controlled for both macronutrient and fiber content, meaning that any of the results that we found cannot be contributed to the GI alone. Thank you.